Hello. When you first open Microsoft Excel, you will notice that you have an empty worksheet. And in this case, you need to create your first worksheet from scratch. Now let's select cell A1, so column A meets row 1, and let's write some text. So here, simple budget plan. So you'll notice that at the end of this text, you'll have your cursor flashing. And till now, Excel did not know if you finished writing or not. So in order to tell Excel that you have finished writing, you need to press the Enter key on your keyboard. So when you press Enter, your text is entered permanently in cell A1, and you will move down one additional row. Now we are in cell A2. Let's write some text. So budget calculator for current year, and let's press enter. So we move down one row, and you can see here that the text budget calculator for current year appears to be in cell A2, B2, C2, and maybe D2. So this is not the case. If you select cell A2 and you look at the formula bar, all the text appear in the formula bar. So all the text is in cell A2. However, if you select B2, C2, and D2, the formula bar is empty. So what Excel is doing, it is like borrowing some some cells to the right in order to show all the text. However, if we want to change the width of column A in order to fit this text, we can hover our cursor to this small vertical line that is splitting column A and column B. And you will notice that your cursor will change to a double-headed arrow. And when this is the case, we can press the left mouse button and drag the double-headed arrow to the right. And this will increase the width of column A in order to fit the text in cell A2. We can undo our changes by clicking the undo button here in the quick access toolbar, or we can click Ctrl-Z to undo the changes. Another method to quickly adjust the width of column A in order to fit the longest text in column A. So we can hover until the cursor becomes a double-headed arrow, and we can just double-click. So if we double-click, Excel will automatically adjust the column widths in order to fit the longest text. Okay? Now, let's go, for example, to cell A4. And let's write here month, for example. If we want to go to column B while maintaining the same row, here row 4, number 4, we press the tab key on keyboard or the right arrow on the keyboard. Okay? So either we press the tab key or the right arrow. So let's press the tab key, and let's write January, February, March, April. Of course, there is another method to easily write all the months in the year. However, we will keep this to later videos. April, May, June, July, August, September, October, November, and December. So now we are here at cell M4, and the cursor is flashing. So we can press enter to finish. However, we will move down one row. What if we want to finish from entering this text, and we want to be still put in cell M4? We don't want to go down one additional row. So in this case, instead of pressing enter, we can press Ctrl enter. So in this way, you can see that we have entered our text permanently in M4, and we are still in cell numbered M4. Okay. Let's adjust here let's auto adjust the width of column J, for example, and column L, in order to auto fit the text. So here we just double click, and for column N we double click here when the cursor becomes a double-headed arrow, and same for December. Okay, now let's select A5 and enter some text. For example, enter your income. All right, press enter. We have income 1, for example, income 2, and total income. So let's press enter twice to move to cell A10. Or you can, instead of just pressing enter, you can use the down arrow key on your keyboard. Now for your expenses, enter. We have, for example, housing, we have transportation, we have utility bills, utilities, we have subscriptions to internet, to cable, we have food, medical stuff, entertainment, we have, for example, loans, savings, and others, bill. And here one cell for total expenses. So let's press enter twice, and the last information is your bottom line. That means income minus expenses. I will just zoom out a little bit in order to show all the text here. Okay. I will show you some navigation techniques in order to navigate through this Excel sheet. And if, let's say, for example, we are here at cell M4 and we want to navigate back to cell A4. So we want to navigate from column M to column A while maintaining the same row. So while we are at M4, we can press the home key and we will move back to cell A4. And another way to do this, we can just press Control and the left arrow key. Okay? Or we can, for example, in order to move from A4 to M4, we can press Control and the right arrow key. Okay? Also, what we can do is we can press Control Home to select the first cell in this sheet, and we can press Control End to select, as you can see, the last cell in this worksheet. Okay? Now we have known some navigation techniques. Let's try some editing techniques. So let's select this cell M4, and let's say that we want to change the content of this cell. For example, we want to write total instead of December. We can press the delete button to delete the content of this cell and write, for example, whatever we need. Let's press Ctrl Z, or we can just start typing total, and Excel will automatically replace the content of M4 with whatever you are typing. Okay, so let's press Ctrl Z in order to undo the changes. For example, if we want to edit some word in a cell. So for example here, for cell A5, so instead of writing your income, I will add S at the end. So I will write your incomes. Okay, so we can just here double click in order to put the cursor at the end of this text. So if we double click, you can see that the cursor is now inside the cell and it is flashing at the end. So we can write S. So I will press the escape key in order not to save the changes. And or in other way, we can move to the formula bar and here put the cursor at the end of the word by pressing the left mouse button and press and type S. Okay. Or another way is to select this cell and press the key F2. So F2 will put the cursor inside the cell at the end of the text. Okay, and you can write whatever you want. So let's press escape. Let's say we want to change, for example, a specific word in a text inside the cell. So if we want to select, for example, here the cell A2, and we want to write budget calculator for this year instead for current year. So we need to change current and put this year. Okay. So what we can do, we can just we can press 2 double clicks. Okay. So the first double click will put the cursor inside the cell, and the second double click will select the required word. Okay. So the first double click here will put the cursor inside the cell, and the second double click will select the current word, and we can write this, for example. So I will just press escape. Okay. Another way is, for example, to select this cell A2 and to go to the formula bar. And in the formula bar, you hover over your word that you want to change, and you press double click, and you can change also from the formula bar. Okay. So now you know some navigation techniques and some editing techniques. They will make your life more easier when using Excel. The majority of charts used by engineers are XY scatter graphs. In this tutorial, we learn how to create and edit an XY scatter graph. So here we have temperature versus time data. Column A contains the time in seconds. Column B contains the temperature in degrees Celsius measured experimentally. And in column C, we have the predicted temperature, may be calculated using some mathematical model. So we need to plot this data in order to see if the predicted temperature agrees well with the experimental temperature. So the first step is to select all the data from cell A3 to cell C19. Go to the Insert tab, to the Chart section, click on Insert Scatter, and here we have several types of scatter graphs. So the first type, as you notice in the preview, we have markers only, so no curves connecting the points in the data series. In the second type, the markers are connected by smooth curves, and the curve will bend as it moves through each data point. In the third type, no markers, only smooth curves. In the fourth type, we have markers that are connected by straight line segments. However, in the last type, we have no markers, only straight line segments. So for this tutorial, we'll choose the second type, which are markers connected by smooth curves. So when we create the graph, you can see this border surrounding the graph, and we have these small dots at the corner. So if you move the mouse pointer over any of these dots, the mouse pointer will become a double-headed arrow, and you can drag with your mouse to increase the size of this chart. Now, this basic graph contains several chart elements. For example, it contains a chart title, a vertical axis, a horizontal axis, chart legend. Also, it contains a major vertical grid lines and horizontal major grid lines. So vertical major grid lines and horizontal major grid lines. Also, it contains two curves. The first blue one corresponds to the measured temperature, and the second orange one corresponds to the predicted temperature. So, However, this basic graph is missing some chart elements. For example, it is missing a vertical axis title and a horizontal axis title. So to add a chart element to this chart, go to the Design tab under the Chart Tools section, go to Chart Layouts, click on Quick Layout, and here you can choose any layout that you like. And each layout is associated with different chart elements. So for example, Layout 1 contains vertical axis title, horizontal axis title, and the legends are located to the right of the plot instead of being located at the bottom. So let's choose this layout 1, for example, and now let's edit the chart titles. So to edit the chart title here, click on this chart title and a border will appear, meaning that this chart title is selected, and replace it with another relevant text. So type in temperature versus time. So don't worry, the text is not showing as you are typing. It is showing in the formula bar. So when you hit the enter key on the keyboard, it will show and it will replace the chart title. So do the same for the vertical axis title. Select it and type in temperature in the vertical axis. Open up the parenthesis. Let's insert the degree symbol. So to insert the degree symbol, hold down the Alt key on the keyboard and press on 0, 1, 7, 6 and release the Alt key. Then insert a capital letter C and close the parenthesis and hit the Enter key, and the text will show in the vertical axis. Let's do the same for the horizontal axis title. Select the axis title, type in time, open the parenthesis, and type in seconds and hit the Enter key. So now we've created this scatter graph, we've edited the chart title, we add a vertical axis title and a horizontal axis title. Let's see in the next video how to format this chart. In this tutorial, we'll learn how to plot XY graph with two y-axes. So here, a researcher is recording temperature using a thermometer and is recording the amount of light using a light meter. So we have two sets of data with different x values, as you can see in column A and column D. And the y values of the two data sets have different ranges. For example, the data for temperature has a range of variation from 11 degrees to 26 degrees, and the data for the light has a variation range from 0 lumens per square meter to 115 lumens per square meter. So that's why we need to plot this data on two different y-axes. So to do this, the first step is to select the first data series, which corresponds to the temperature measurement. So select the first two cells and Ctrl-Shift and press on the down arrow key on the keyboard to select to the last used row. Go to the Insert tab, to the Chart section, click on Insert Scatter, and now let's insert a scatter plot with straight line segments. Let's do the same for the lumens. In order to add the lumens per square meter data to an existing plot, what we need to do is to go to the Design tab under the Chart Tools section, click on Select Data, and here we can add data series to an existing plot. So click on this Add button. You can choose a series name. So let's type in light. And for the x values, we need to select the x values. Click on this up arrow, choose cell D4 and Ctrl-Shift the down arrow key to select to the last used row. Then press on the down arrow here. And for the y values, press on this up arrow, select cell E4 and Ctrl-Shift down arrow key on the keyboard to select to the last row. Then press on this down arrow here and hit the OK button, then hit OK. So now you can see we have these two curves on the same plot. However, these two curves use just one y-axis. So in order to associate the light data on a secondary y-axis, what we need to do is to double-click on this curve, on this orange one. So this will open the format data point panel here to the right, and in the series options, choose plot series on secondary axis. So now each plot has its unique y-axis. Now, this plot is missing some chart elements. It is missing the axis titles and the legends. So let's add the axis titles. Click on this plus button here and check axis titles. And let's replace the text. So choose this one and type in temperature. Open up the parentheses, hold on the Alt keys and 0176 to add the degree sign. Then add capital letter C for Celsius and close the parentheses and hit the Enter key. For the horizontal axis title, we'll type in time in hours. And for the secondary axis here, we'll type in lumens per square meter and hit the Enter key. Now let's add the legend and put the legend here at the top of the chart. So click on this plus sign and check legend. Now by default the legend are inserted to the right. So to move them to the top, click on this sideways arrow and choose top. Then let's click on this plus sign to deactivate the menu. Now if you notice the horizontal x-axis varies from 0 to 30 hours. However, the data varies from 0 to 24 hours, so we need to format this. So select the horizontal axis, click on axis options here, expand axis options, and change the maximum to 24, hit the Enter key, and the minimum, make sure it is 0. And let's increment the major vertical grid lines by an amount equal to 2 hours. So change the units for the major to 2 instead of 5 here and hit the Enter key. So now the time will increment by an amount equal to 2 hours. Now one last thing, I always like to put additional formatting for a given curve that make this curve distinguishable when you are printing the plot using a non-color printer. So if you plot this curve using a non-color printer, you will not be able to distinguish your data. So let's format, for example, this orange one and make this line a dashed line instead of a solid line. So choose this curve, go to the fill and line button here, and for the dash type, let's choose this square dot dash type. And now if you plot this graph on a non-color printer, you will still be able to distinguish the temperature data from the light data. Let's imagine a student has measured the voltage of a battery many times, and he recorded his results in a table as shown in column A and column B. So his objective is to compute the weighted average of the results. So here the weighted average formula, the average voltage is equal to the summation of the product of V into N, where V is the recorded average and N is the number of observations for that particular voltage divided by the total number of observations during this experiment. So the first step, we need to calculate the numerator. So that's why we've created in column C the values of V into N. So select cell C2 and let's multiply cell A2 into cell B2. So to do this, we start always with an equal sign to tell Excel that this is a formula. then select cell A2 and enter the multiplication operator, which is an asterisk symbol. So to insert an asterisk, hold on the shift key and press on the 8 key on the keyboard. Then select cell B2 and hit Ctrl Enter to stay on the same cell. So this, if you look at the formula bar, this will read as A2 into cell B2. Now you don't have to repeat the same formula in every cell to calculate all the products of V into N. You can make Excel autofill the results for you automatically. So to do this, select cell C2 and you can see this small dot located at the bottom corner of cell C2 and it is called the autofill handle. So move the mouse pointer over this small dot and the mouse pointer will become a plus sign, then just double click and Excel will autofill all the results. So for example, if you select cell C3, you can read in the formula bar A3 into B3. If you select cell C4, you can read in the formula bar A4 into B4. So Excel is correctly guessing to multiply the adjacent cell next to the formula bar. Now, the next step, we need to sum the observations and sum the products of V into N, so we can divide the summation of the product over the summation of the observations. So select cell F1 and let's compute the sum of observations. We'll use the sum function. So equals sum, open the parenthesis and select cells from B2 to cell B12 and close the parenthesis and hit the enter key. Now the summation for the product, again, equals sum, open the parenthesis and select the values in column C and close the parenthesis and hit the enter key. Now the average is just the division of cell F2 by cell F1. So equal, select cell F2 and divide. To divide, you just insert a forward slash, which is located next to your shift key, and select cell F1. So this is F2 divided by F1. So this is one way of computing the weighted average. Now I will show you another way by using the sum product function. So in order to use the sum product function, we can either use the insert function located in the formulas tab, or you can just type in the name of the function, which is sum product. So we'll do it in two ways. The first way, we will use the insert function. So select cell F5, go to the formulas tab, click on insert function, and this will open the insert function dialog box. So make sure you are in the math and trigonometric category and scroll down and choose sum product and hit the OK button. So this will open the function arguments dialog box, and you can see that the sum product will take as input arguments up to 255 arrays, where it will multiply and add the components and return the result. So using this wizard, we can select up to three arrays. So however, in this experiment, we only need to select two arrays, which are the voltage and the observations. So select the first array, then let's select the second array, the observations, and hit the OK button. So this will return 61.8, which is similar to the one we calculated in cell F2. Now the average is just equal to the sum of product divided by the sum of observations in cell F1. Now we will use the round function in order to round the number in cell F6 to 2 decimal places. And to do this, let's go back and click on insert function, Let's scroll down to locate, to search for round. So this is the round function. Click on OK. And the round function will take two input arguments. The first one is the number that we want to round, which is cell F6. Select cell F6. Then the second input argument, we need to specify the number of decimal places that we want. So if we type 2, it will show 2, it will round to 2 decimal places. So it will show the number as 1.67. So let's hit OK. So this is the second method. The third method to calculate the average, we will type in all the formula in cell F9 in one step. So start by typing in the equal sign. Then we will use the round function and open the parenthesis. So as you can see, the round function takes two inputs argument. And the first input argument is the result, and the second input argument is the number of digits, and they are separated by a comma. So whenever a function takes more than one input argument, you need to separate the input arguments by a comma. So the first number is the average voltage. So to calculate the average voltage, we will use the sum product. So as you can see, we are able to nest two functions. So we are nesting the sum product function inside the round function. And you don't have to type in an equal sign every time you insert a function. You just type in an equal sign just at the beginning of the formula. So this sum product, let's hit the tab key to auto-spell the sum product. And here the parenthesis is changing colors. So this happens when we are nesting functions. So you can know which parentheses belong to which function. So sum product, it has red parentheses, and it will take as input arguments several arrays. So the first one, we will select array 1. Then the second input argument will be array 2, which is located in column B. So to separate the input arguments, let's type in a comma, and then select the numbers in column B. Now we're done. Let's close the parenthesis, and you can see that the right parenthesis and the left parenthesis have the same color. So this is divided by the sum of observations. So type in sum, open up the parenthesis, and let's add the observations here and close the parenthesis. Now we're done entering the formula for the voltage, and remember, we've done inserting the first argument in the round function, which is returned by this formula. So let's insert a comma and insert the second argument for the round function, which is the number of digits or the number of decimal places. And let's type in 2, for example, and close the parenthesis. Now let's hit the enter key. So this will return also 1.67. In this tutorial, we'll create a quadratic equation solver using the f function. So we have this quadratic formula of the form ax squared plus bx plus c is equal to 0. And a, b, and c are coefficients, and they have constant values. So the first step, we need to calculate the discriminant, which is b squared minus 4ac. And based on the sign of the discriminant, we can say that if the discriminant is positive, we have two real solutions, where the solutions are minus b plus or minus a radical or square root of the discriminant divided by 2a. However, if the discriminant is equal to 0, we can say we have one real solution or two identical real solutions. However, if the discriminant is negative, we have two complex solutions where the solution will have an imaginary part. In this example, we will not deal with complex solutions, we will only deal with real solutions. So the first step is we want the user to input A, B, and C, which are the coefficients in the quadratic equation. Then, in cell E4, the worksheet will calculate the discriminant, and then in cell C6, based on the value of the discriminant, we will display the number of real roots. Then, in cell B7, we will display the value of the first root, and in cell D7, we'll display the value of the second root. So let's first start by giving a meaningful name to cell A4, B4, and C4. So select cell A4, go to the name box and choose the name A and hit the Enter key. Select cell B4 and go to the name box and give it the name B. For cell C4, if you go to the name box and type in C and hit the Enter key, this will select the columns. Since the letter C in Excel is reserved for column names and the letter R is reserved for row names. So we need to select another name or we need to modify the name. So for this, I will select cell C4 and type in C with an underscore and hit the Enter key. Now we will calculate the discriminant. So I've taken the example A is equal to 1, B is equal to minus 3, and C is equal to 2. So the discriminant in this case will be equal B squared, which is 9, minus 4 times A times C. So minus 4 times 1 times 2. So we'll have 9 minus 8, and the discriminant will be equal to 1. Then we have two real solutions since the discriminant is positive. So let's calculate the discriminant. Select cell E4 is equal to B squared. So B times B, you can write B times B, or in another way, you can just write B and insert a little hat by holding the Shift key and pressing on the sixth number on the keyboard. And then type 2. So this will read B raised to the power of 2 minus 4 times A times C underscore and hit the Enter key. So this is equal to 1. I will give also a name to cell E4. So select cell E4, go to the name box and type in disk and hit the Enter key, which is the abbreviation for discriminant. Now let's calculate the number of real roots. Select cell C6. So we will use the f function now. If the discriminant is positive, we have two real solutions. If it is equal to 0, we have one real solution. And if it is negative, we have complex solutions or zero real solutions. So equal, type in the if function. Then the first test, we will say that if discriminant is greater than or equal to 0. So we will do another test. If the discriminant is greater than 0, we have two roots. Otherwise, we have one root. That means the discriminant is equal to 0. Then close the parenthesis and insert a comma for the third argument. So the third argument corresponds to the discriminant to be less than 0. Then we will return a 0 value, meaning 0 real roots. And hit the Enter key. Now, in cell A7, so this will display text. So we'll display the text double roots or two identical roots if the number of real roots is equal to 1. However, if the number of real roots is equal to 2, we will display in cell A7 the text root 1, and in cell C7 the text root 2. Then we will output the values in B7 and D7. However, if the number of real roots is equal to 0, we will keep this cell as a blank cell or an empty cell. So select cell A7, type in the equal sign, if, select cell C6, if cell C6 greater than 0, so it could be 1 or 2, then we do another test, a nested if C6 is equal to 1, we will say we have double roots. However, we will say root 1. So this is the first root if we have two real roots. Then insert a comma. Then the third argument corresponds to C6 is equal to 0. And if C6 is equal to 0, we will return an empty cell. So just insert the double quotation mark twice and close the parenthesis and hit the enter key. Now, B7, we want to display the value of root 1, which is equal to if C6 is greater than 0, meaning we have either one real root or two real roots. So the value will be equal to, open up the parenthesis, minus b. The first root will be plus square root of the discriminant. We will use the function called sqrt, the square root function, and open up the parenthesis. It will take as input argument the number. So we want to square root the discriminant, close the parenthesis, then close it another time, and divide by 2a. So divide and open up the parenthesis and type in 2 times a, then close the parenthesis. Then insert a comma for the third argument. So the third argument corresponds to if C6 is equal to 0. If C6 is equal to 0, we return an empty cell. So just 2 double quotation marks and hit enter. Now for cell C7, so this will display the text root 2. So equal, if, select cell C6, if C6 is equal to 2, then we will display root 2, else we will return an empty cell. So else if we have, for example, double roots, if C6 is equal to 1, or if C6 is equal to 0, we have complex numbers, and in the two situations, we will display an empty cell. So hit the enter key. Now in D7, we will output the second root, then equal if C6 is equal to 2. So this will be equal to minus b. Now the second root will be minus square root of the discriminant divided by 2 times a. As return an empty cell, close the parenthesis and hit enter. So of course the solution for x squared minus 3x plus 2 is equal to 0 will have two roots. The first one equal to 2, the second one is equal to 1. Of course, you can make sure if these are correct by replacing the solution in the original equation and see if you obtain a 0 value or not. For example, let's enter coefficients so that we have double roots. So for this, I will enter 2 in cell B and 1 in cell C. So this will be x squared plus 2x plus 1 equal to 0. So we have one real root or double roots, and the root will be equal to minus 1. Of course, we can, for example, try if we have a negative discriminant. If we put, for example, in cell C4 the value 4, hit the enter key. This will output a discriminant of -12 and will display 0 number of real roots, and here the cells will be empty. In the previous video, you've calculated the slope, the intercept, and the coefficient of determination for the straight line that best fit our temperature time data. In this video, we will calculate the temperature at specific times at 2.5, 4.3, 8.7, and 15 minutes. So the first three tasks are called interpolation, since these time data are within our time range, which spans from 0 to 9 minutes. However, the last task is called extrapolation, since the time data here, which is 15 minutes, is outside the time range. Usually, interpolations are safe to do, however, extrapolations are risky, especially if the data is very far from your range. So use extrapolation carefully, and when you are very sure that the relationship between your data will continue to be linear over a very wide range. So we will calculate the temperature using two methods. The first one, using the equation of the line y equal to b1x plus b0, and the second one using the forecast.linear function. So let's start by using the straight line equation. Select cell H4 equal to b1 into x, which is the slope. Select cell E3, and make sure you are using an absolute cell reference in order to fix the cell address E3. So press the F4 key on the keyboard, and this will add the dollar signs, and the cell address will not change when we use the autofill handle. Then times cell G4 plus the intercept, which is in cell E4. And here also we want the intercept to be fixed, and we want to use absolute cell reference. So press the F4 key to add the dollar signs and hit Ctrl Enter. Then double click the autofill handle. So if you select any cell here and you look at the formula bar, you can see that the cell addresses for the slope and intercept will not change. However, only the cells that are related to the time data will change. Now let's calculate the temperature using the forecast.linear function. So equal forecast, and here Excel will suggest the function names for you. You can press on the down arrow key on the keyboard to go to forecast.linear, and you can hit the tab key to auto-spell. So the forecast.linear function will take three input arguments. The first one is your x value, which is the time here. Now insert a comma. The second one is the known y values. So your experimental data, select from cell B4 to cell B13, and here press the F4 key when you're done selecting the data to use absolute cell references for this range. So this range should not change when we use the autofill handle. Insert a comma, then drag over your x values and press the F4 key to use absolute cell reference, then close the parenthesis and hit Ctrl Enter, then double click to use the autofill handle, and you can see here the data are identical between the forecast.linear function and the straight line equation. So what we can say is that the forecast.linear function is doing in the background, it is calculating the intercept and the slope and using the equation of the straight line to predict the data.